The leather manufacturing process is divided into three sub-processes: preparatory stages, tanning and crusting. All true leathers will undergo these sub-processes. A further sub-process, surface coating, may be added into the sequence. The list of operations that leathers undergo vary with the type of leather. Production management. The leather-making process is in general restricted to batch processing, but if the surface coating sub-process is added, then some continuous processing can be included. The operation flow has to follow the preparatory, tanning, crusting, surface coating sub-process order without deviation, but some of the sub-processes can be omitted to make certain leathers. Preparatory stages. The preparatory stages are when the hide, skin is prepared for tanning. During the preparatory stages, many of the unwanted raw skin components are removed. Many options for pre-treatment of the skin exist. Not all of the options may be performed. Preparatory stages may include preservation. The hide, skin is treated with a method which renders it temporarily imputrescible. Soaking water for purposes of washing or rehydration is reintroduced. Liming unwanted proteins and opening up is achieved. Unhairing, the majority of hair is removed. Fleshing, subcutaneous material is removed. Splitting, the hide, skin is cut into 2 or more horizontal layers. Reliming, the hide, skin is further treated to achieve more opening up or more protein removal. Deliming, liming and unhairing chemicals are removed from the pelt. Baiting, proteolytic proteins are introduced to the skin to remove further proteins and to assist with softening of the pelt. Degreasing, natural fats, oils are stripped or as much as is possible from the hide, skin. Frizzing, physical removal of the fat layer inside the skin. Also similar to slicking. Bleaching, chemical modification of dark pigments to yield a lighter colored pelt. Pickling, lowering of the pH value to the acidic region, must be done in the presence of salts. Pickling is normally done to help with the penetration of certain tanning agents, e.g., chromium, aldehydic and some polymeric tanning agents. Depickling, raising of the pH out of the acidic region to assist with penetration of certain tanning agents. Tanning. Tanning is the process that converts the protein of the raw hide or skin into a stable material which will not putrefy and is suitable for a wide variety of end applications. The principal difference between raw hides and tanned hides is that raw hides dry out to form a hard, inflexible material that can putrefy when re-wetted, while tanned material dries out to a flexible form that does not become putrid when wetted back. A large number of different tanning methods and materials can be used. The choice is ultimately dependent on the end application of the leather. The most commonly used tanning material is chromium, which leaves the leather, once tanned, a pale blue color. This product is commonly called wet blue. The acidity of hides once they have finished pickling will typically be between pH of 2.8 to 3.2. At this point, the hides are loaded in a drum and immersed in a float containing the tanning liquor. The hides are allowed to soak and the tanning liquor slowly penetrates through the full substance of the hide. Regular checks will be made to see the penetration by cutting the cross-section of a hide and observing the degree of penetration. Once an even degree of penetration is observed, the pH of the float is slowly raised in a process called basification. This basification process fixes the tanning material to the leather, and the more tanning material fixed, the higher the hydrothermal stability and increased shrinkage temperature resistance of the leather. The pH of the leather when chrome tanned would typically finish somewhere between 3.8 to 4.2. Crusting. Crusting is when the hide, skin is thinned, retanned and lubricated. Often a coloring operation is included in the crusting sub-process. The chemicals added during crusting have to be fixed in place. The culmination of the crusting sub-process is the drying and softening operations. Crusting may include the following operations: wetting back. Semi-processed leather is rehydrated. Sammying 45 to 55% water is squeezed out the leather. Splitting, the leather is split into one or more horizontal layers. Shaving, the leather is thinned using a machine which cuts leather fibers off. Neutralization, the pH of the leather is adjusted to a value between 4.5 and 6.5. Retanning, additional tanning agents are added to impart properties. Dyeing, the leather is colored. Fat liquoring, fats, oils and waxes are fixed to the leather fibers. Filling, heavy, dense chemicals that make the leather harder and heavier are added. Stuffing, fats, oils and waxes are added between the fibers. Stripping, superficially fixed tannins are removed. Whitening, the color of the leather is lightened. Fixation, all unbound chemicals are chemically bonded, trapped or removed from the leather. Setting, area, grain flatness are imparted and excess water removed. Drying, the leather is dried to various moisture levels. Conditioning, water is added to the leather to a level of 18 to 28%. Softening, physical softening of the leather by separating the leather fibers. Buffing, abrasion of the surfaces of the leather to reduce napa grain defects. Surface coating, for some leathers a surface coating is applied. Tanners refer to this as finishing. Finishing operations may include oiling, brushing, patting, impregnation, buffing, spraying, roller coating, curtain coating, polishing, plating, embossing, ironing, combing, glazing. Environmental impact. In addition to the other environmental impacts of leather, the production processes have a high environmental impact, most notably due to the heavy use of polluting chemicals in the tanning process. Air pollution due to the transformation process. 1 ton of hide or skin generally leads to the production of 20 to 80 cubic meters of turbid and foul-smelling wastewater, including chromium levels of 100 to 400 mg/L, sulfide levels of 200 to 800 mg/L, and high levels of fat and other solid wastes, as well as notable pathogen contamination. Pesticides are also often added for hide conservation during transport, with solid wastes representing up to 70% of the wet weight of the original hides. The tanning process comes at considerable strain on water treatment installations. Tanning is especially polluting in countries where environmental norms are lax, such as in India, the world's 3rd largest producer and exporter of leather. To give an example of an efficient pollution prevention system, chromium loads per produced ton are generally abated from 8 kg to 1.5 kg. VOC emissions are typically reduced from 30 kg/t to 2 kg/t in a properly managed facility. Very clearly, the process remains highly polluting all the same. A review of the total pollution load decrease achievable according to the United Nations Industrial Development Organization posts precise data on the abatement achievable through industrially proven low-waste advanced methods, while noting that, even though the chrome pollution load can be decreased by 94% on introducing advanced technologies, the minimum residual load 0.15 kg/t raw hide can still cause difficulties when using landfills and composting sludge from wastewater treatment on account of the regulations currently in force in some countries. In Kanpur, the self-proclaimed leather city of world, and a city of 3 million people on the banks of the river Ganges, pollution levels were so high that, despite an industry crisis, the Pollution Control Board has decided to seal 49 high-polluting tanneries out of 404 in July 2009. In 2003, for instance, the main tannery's effluent disposal unit was dumping 22 tons of chromium-laden solid waste per day in the open. The higher cost associated to the treatment of effluents as compared to untreated effluent discharging leads to environmental dumping to reduce costs. For instance, in Croatia in 2001, proper pollution abatement cost $70–100 United States dollars per t of raw hides processed against $43 United States dollars per t for irresponsible behavior. No general study seems to exist, but the current news is rife with documented examples of untreated effluent discharge. In November 2009, for instance, it was discovered that one of Uganda's main leather-producing companies directly dumped its wastewater in a wetland adjacent to Lake Victoria.